there. So you can see it's deployed. We have our program ID here. One thing to always double check is to make sure all of your program ID keys are synced throughout the workspace. So now that it's deployed, we're just going to run anchor keys sync. And you can see all program ID declarations are synced. Now that it's deployed, we're able to connect this program to a front end. So let's go into, we can close out the anchor folders and we're going to go into the web folders. So in our web folder, in the npx create Solana dapp scaffold, we have app, we have components, and we're going to be working between those two folders. So first, we're going to go into components and we're going to go to counter. And we'll go to data access. So we're just going to make some updates here. This was previously created for the anchor counter program that comes with the scaffold. So this is just updating. It's fetching all of the information from the state. So we're changing the state from counter to journal entry. And we're going to do that everywhere. You can see that we have instructions from the counter, like close and increment and decrement. All of those can be deleted, and we're going to rewrite them for the instructions for the CRUD app. So we'll go in here, the close mutation can go away. The decrement mutation can go away. And you can see that it's returning an error because it's not finding these instructions in the corresponding IDO. So TypeScript knows that something has changed, and we just have to update those changes. Okay. There you go. Now we can just go in here and we're going to do our create entry. And we're going to use a mutation. And now we're going to be collecting information from the front end that's a user input value. So we're going to need to specify what's being collected. We're going to need to make this an async await so it's able to take everything from the front end and then pass it through. So we'll do we'll set up our create entry args. And that's going to have to be an interface that we're going to define outside of this. We'll do an interface for create entry args. And that is going to be the title that we need to pass through, which is a string type. The message, which is also a string. Then the owner, which is a public key. This initialize can also go away. Everything that's related to the counter can just be erased. Okay. So since creating the entry is part of the overall journal program and you're initializing a new account, we're actually going to have that in the use program. So we can go in here and do const create entry. We're going to use the mutation with the create entry args. We'll need to specify the mutation key. Oops. This is just a journal entry. And then we have create and we have the cluster. And then we'll define the function. And this is going to be an async function. And what we're grabbing from the front end is going to be the title, the message, and the owner. And now all we're going to do is return the program method for creating a journal. We can delete this return that happened earlier. Create journal entry. And then RPC to send the transaction. Okay. So that's what we're doing. We have the program methods. We're calling the create journal entry instruction, and we're passing through the title and the message from the user input parameters that we're grabbing from the front end. Now, since this is an async function, we just want to have an on success and an on error. So we'll add that in. Success. So if this is successful, it's just going to sign the transaction. And then refetch all of the accounts for the program. And then if there's an error, we'll add the logic in for that. And just make sure we return the error message. Okay, so that's everything we need for create entry, and then we just need to return that. So we're returning our program, our get program accounts, and our create entry. So everything's set up to be able to use the program. Now we want to go into using a specific account. So what this use program is doing is just initializing a new account. If you want to update an account that already exists, we need to derive it from the PDA and then be able to go in and update it. So that's going to be this second function here, which is using an account. So we'll update that. We're able to query specific accounts. And now we want to be able to update an entry. So once again, we're taking the user input from the front end and adding in the create entry args that we specified earlier. And we'll need, let's see what Copilot did. So we have the mutation key for the journal entry. We're specifying that it's update and we're using the cluster. Now we need to specify the function. It's an async function. We're taking in the title and the message and the owner from the front end. And then here we're doing update entry. And actually, in this case, we don't need the owner, so we can delete that. And we're just taking in the title and the message. And then we want to have an on success and an error case, and that's defined here. If it's successful, it's going to sign the transaction. If it's not, it's going to return the error. And looks like that's good to go. Okay. And then last, we just want to do the delete entry. So we'll add another constant in here for delete entry. Okay, let's see what Copilot did. We have the mutation key. We have journal, delete, and the cluster. It's an async. However, yeah, we don't need to take anything in from the front end. We're going to take the program. This should be program methods, not RPC. Copilot was close. Delete journal entry. And we're going to need to take in the title from the front end, and the title is needed to be able to derive the PDA. So we'll take that in. Okay. So we have our function of the delete entry. It's taking in the title as a parameter. That's part of our async function here. Actually, there's a way we can do this without making it an async. If the card already exists on the front end, it will have what the title is. So it can just pull that without needing to be a user input value. So we can remove the need for an async here and just have the title. So the title will be already on the front end. You'll have it on the card. And when you click delete, it'll know which journal entry it's corresponding to. So we have the title, the program methods, delete entry, passing through the title here, and then there we go. So we have our signature. On success, it's going to be a transaction, and accounts refresh, we don't need an error, and we actually don't need this. This is what Copilot generated, but since we're only passing through the title, we don't need the create entry args. So yeah, we're good to go there. Now all we need to do is return these constants. And now everything's updated on the front end. So in the front end, we have things separated by accessing data through our smart contracts. All of the data access is completed. Now we just want to update that data on the UI side. We'll go into the UI file, and we're going to update all of the information here. So let's see. We still need our key pair connected. We won't need the memo. Can get rid of that. Okay. So we're going to change a few things here. So this first counter card, it's actually going to be for creating a journal. So we're going to want to have the user input fields here. This is where we're actually going to grab the data from the front end. So we're going to want to have our title and a way to set the title. And we'll import useState from React. And we'll do the same thing for message. And then we're going to want to use our create entry instruction that we just created from the data access file. So we'll pull that in. And then we also want to be able to use a public key. So and this we're going to use from use wallet. And this is coming from the wallet adapter library. We have our front end. We need to have the title and the message be a user input. So we want to make sure that these values are actually input correctly from the user. So we're just going to have a check here. So we're going to do is form valid. And that's going to make sure that the title exists. And the message exists. And then we want to be able to handle the submit of the information on the front end. So we'll make a function for that. So if there's a public key connected on the front end and the form is valid, then we're going to be able to execute the create entry logic. Okay. And that's all we need there to handle the submit. So we need to do one more error handling, and that's going to be if there isn't a public key connected, we need to return that the user needs to connect their wallet. So we'll do an if there's no public key, we will return connect your wallet. Okay. So now all we're doing is just handling the UI side of things. So when we return, we can delete everything that came with the counter because we are not going to need that. Okay. So when we return, we want to have an input for text. We want to have a text area for the message. And then we want to have a button for someone to submit. So we'll do a div have an input. And that input is going to be of a text type. Oh, there we go. So Copilot has it. We need the text type. We need the placeholder is going to be the title. The value is going to be title, and on change it's going to set the title by using the useDate from React. So that's good for the input. And I'm just going to add in the class name actually, just so it sticks with the styling for the rest of this. We have our input bordered. I want it full, and I also want max width extra small. There you go. Okay, so input is done. Now we need a text area input as well. So we'll do text area. And then Copilot has it. We have placeholder message. The value that the user is going to input is the message. On change, it's going to set the message in the state. And then we have our class name. So we have a text area bordered. And then I also still want to add in the max. There we go. So text area is done. And then lastly, we need a button. So we have our button, and let's see. On click, we want to handle submit. We want to have it disabled if the form is not valid. And we also want to add in if create entry is pending. Oops. So is pending or is form valid, it'll be disabled. We have the class name is going to be a button. I don't want it to be a primary button here, so let's change that. So we'll do a small button. There we go. Okay. And then we just need to close our div, and then this section is good to go. So okay. So this is done. So what this is doing here is the card to be able to create new journal entries. Now we just need our last UI update, which is going to be the card of a specific journal entry and how to update a specific journal entry. So that's our create. Now we'll go to the list. So in the card, you can see it has all of the counter information from before. So we're going to delete that. And we'll delete the memo because we don't need it. Actually, we'll delete all of this. Just get rid of it. Okay. Great. So in the card, we're passing through the account query. We're going to pass through update entry and delete entry. And that's going to be from the program account. And it's going to be passing through the account. And now we're going to have the public key. So we'll do the use wallet just like we did earlier. This is the public key. There we go. Okay. And now, just like we did earlier, we need to set the message because a user is going to be able to go in and update a message. So they need to have that space to update it, and we need to be collecting it on the state. So const message and set message. And we'll do use state. Okay. This was the optimization we talked about in the contract. It doesn't need to be a user input value. We're actually just querying it from the account, and the title cannot be updated. It's just there because it's part of the PDA for an account. So we'll just add in title, and that's going to be an account query. Okay. And I spelled const wrong, so we'll fix that. Great. So we have our public key, our message, our title, and then we'll do the same is form valid check. So we'll just copy that over. We don't need to retype it. But actually here we're not having a title, so we'll just update this to only be for message. Okay. And then we also need the handle submit, so we can copy that as well, just some less typing. And we'll need the public key, so while we're up here, we'll copy that as well. So here we go. Handle submit, public key. And now, let's delete this. Everything related to the counter, we're just deleting. Now we can do our return. And this is going to be an account query. And it's just going to load all of the accounts associated with the program. This is just going to be a lot of UI work. So we're going to span class name loading. There we go. And then else we're going to return the card. So let's actually see what Copilot did. So we have the class name card. We're going to just make this a little fancier. So let's make it a bordered card. Bordered base, let's do like 300. And then spelling things wrong. Okay. So class is done. And now we're going to do the card body. We'll just center things here. Okay. We'll do this a little differently. Okay. So we're going to do the class name. We'll just add a space in here. Okay. And now we have our header. We have a card title. We'll center the card title. Okay. And now we're also just going to want to add in a refresh here. So on click, it's going to refetch all of the account queries. So on click, we're going to do accounts query, refetch. There you go. And if you're following along and see things auto completing here, it's just Copilot. I'm going to change what Copilot did a little here. So this is actually going to be an account query for the title. Okay. Clean up some code a little bit. So we have our title here for the card. And now we have the title. We're going to want to add in the message. So we'll just add that underneath. So let's delete this Copilot recommendation and just add in the message. And this will be an account query as well. Okay. Great. So that's done. Now just visualizing the card, we have the title at the top of the card, we have the message displaying. Now, since we want to be able to update a journal entry, we want to have some space for a user to type in their updated message and a button to click that. So we're going to add that in. It looks like Copilot did a pretty good job here. So let's just go over. We have our card actions. We'll just add a justify here. Just clean up the UI a little bit. Okay. And then we have our text. We'll change this to a text area. Text area is going to have a placeholder for message. It's going to have the message value. On change, it'll set the message. And then we'll do a class name. And there we go. So there's our text area. And then we have the button to handle submit for the updating an entry. And that's going to be labeled update. We can just specify a little more, update journal entry. Okay. And then we have delete entry. So this will be a delete button, and we can just do an account query here for the title. There we go. And now since title could be undefined, we're just going to add in a little check here for error handling. So we'll do this, and we're going to do if So we'll just change this a tiny bit. Okay. So we'll do a const. There you go. So if it exists, then it'll actually execute the instruction. Okay. Clean that up a little bit. So now we'll clean up our imports that we don't need. Okay, and then we need to find the name for query entry because it looks like we didn't name it that. So let's go back and see we have update, delete. We have create entry. So let's just make sure it was imported. Okay, so this should actually be update entry. There you go. And then we're gonna have to do the same thing from earlier because title could be undefined. So we're just going to add in a check there. So if title exists, then we'll actually do this. So, and title. There we go. And it looks like this is good to go. So one more check, we're gonna check in on the feature. We just need to make sure we're returning program ID, which we're not. So we'll add program ID in here. And we're good to go. So let's try to build this. So we're going to navigate into our web app. And we'll run npm run dev and see what we've got going on here. So let's open up a browser and we'll go to our localhost. And you can see our web app is now running on our localhost, port 3000. And here's our app. So this is what the front end looks like when you're using npx create Solana DApp. You have this basic UI. You have the accounts. This shows you your connected wallet account. So this is my DevNet wallet. You have your clusters. Right now I'm connected to DevNet, but I built and deployed my program on LocalNet, so I'm going to change that connection over to local. Okay, and we're just going to request an airdrop, make sure I have funds on local. Then we can click over to our program. And you can see here, program not found. So we're going to go back here and just make sure we have everything correctly updated. So we'll open a new terminal. We'll cd into Anchor. We'll do Anchor build. And then Anchor key sync, make sure all of the program IDs are connected across the workspace. So, and then we'll just do Anchor deploy, specify the provider cluster to be localhost. So it deploys to local. Local net for Anchor. Localhost is Solana CLI. Okay, so here's our program ID. Let's just refresh this. Okay, so you can see here the program IDs don't match up. So that means something in our data access is pulling an incorrect program ID. So it's probably coming from the counter. So we're going to go back over here to our use counter program, and where is it finding the program ID? So get ID, cluster, devnet, public key. So this public key needs to match the public key in our Anchor program. So we'll go back to our Anchor program and just make sure it's connected. So see how they're different? That's where we're going to update. So in the npx create Solana D app, the one part that doesn't update with Anchor key sync is right here. So you go to your counter exports and you just want to update, you want to update the public key to the new public key. Okay. So now let's see if this updated. We're going to close out this instance and just rerun our we'll cd back to our web. And then we'll run npm run dev. Okay, so now we're on our localhost. We'll go here. I'm going to refresh. Okay. So we're just going to find where it's generating this account. So I'm going to copy this over and Command-Shift-F. And search this. Okay, so here it is. This is what we also need to update. So here you have these TypeScripts, and it has an address that is our old public key. So we'll go in here, take in the public key that we want, that we actually deployed, and I'm going to go into, let's see, how do we do this? We will just paste this here so I have it. We'll go back here, copy this, Command-Shift-F. We're going to paste one we don't want. We'll click in here, and then we'll paste this one in. Okay. Make sure all of this goes away. Save. Okay. Now we'll go back over here, refresh, and here we go. We have our updated public key. So this is our account. Now we're just going to create a message. So I'm going to do Bootcamp. And I'll make the entry learning Anchor. And we'll just submit that. It's going to pop up your wallet to sign the transaction. So I'll confirm, and there you go. So there's my entry. It's titled Bootcamp. My message is learning Anchor. Now I have the option to either update a journal entry or delete. You can see the update is disabled because I don't have the correct information in the message. So once I start putting something in that field, it'll pop up. So let's update it to I learned Anchor, because now I know what I'm doing. And now you can see the button shows up. So I have the ability to update, my wallet comes up, sign the transaction, we'll refresh, and now we have a new message, I learned Anchor. And now last thing, delete. So if I don't want this anymore, I'm going to delete it. Now it's gone. So that's everything. We created, we updated, we deleted, and we're able to read on the UI. So we have our fully working CRUD app. We have it connected to the front end, and we're able to play around with the UI and test everything. So we did it. Good job, guys.
Let's talk about tokens and also make our own token. So far, the only token we've discussed is Sol, which we use to pay transaction fees when making our favorites and voting contracts. Sol is the native token of Solana, which means it's built into Solana itself. But if you use blockchain in the real world, you've probably used many tokens other than Sol. On Solana, these are called SPL tokens. If you're wondering about the name, SPL is the Solana program library, a bunch of smart contracts which include the program you use to create and transfer tokens. For the rest of the course, we'll just refer to SPL tokens as tokens. Tokens are used to represent everything apart from Sol. There are tokens for stablecoins like USDC, NFTs, and real-world assets like equities, metals, commodities, dog tokens, and nearly anything else. Tokens are produced by token mints. Token mints are factories that make a particular token. The factory is run by a person called the Mint Authority. The Mint Authority must sign all the transactions that mint new tokens. Each distinct token on Solana has its own mint. For example, when I purchased my beer earlier, I paid with USDC, a popular stablecoin, a token whose value is tied to a fiat currency like USD. USDC is made by a company called Circle, and they have the token mint address published on their website. The company Circle is the mint authority for USDC. When we create our own mint with the token program, we'll set ourselves as the mint authority. The Mint Authority can mint, i.e. create, new SPL tokens into any address, including their own. When an account receives the tokens, it will need somewhere to store these tokens, since regular accounts only store Sol. So we'll create an associated token account to store that. An associated token account is just a PDA with the seeds made from the wallet address and the token mint address. For example, I can always find Alice's USDC token account by looking up the PDA based on her wallet address and the USDC mint. And I can always find Bob's USDC token account by looking up the PDA based on his wallet address and the USDC mint. And I can always find Alice's dog token account by looking up the PDA based on her wallet address and the dog token mint. You get the idea. Let's make a token. So let's make a token. We'll be using the command line tools here, but the concepts are exactly the same as if you were using the JavaScript or TypeScript tools. We'll also be using the new token program called Token Extensions that features a bunch of useful features that we can add to our tokens. One of those is the metadata feature, which allows us to have our metadata, all the things you see about the token, like a name and a description, directly inside the token mint. And if you don't know what that means, that's fine. All it means is that we'll be taking less time because we have less things to work on. So let's open a command line. Let's see that we have Solana command line installed. Great. Let's make a new directory called new token. And let's change into that directory. We are now in a big old empty directory, and the first thing we're going to need to make is what's called a mint authority. If you think of a token mint, like the actual physical mint that prints tokens, you can think of the mint authority as being the boss of that mint. They're the person that needs to sign all the transactions to mint new tokens. If you're not the mint authority, you can't mint tokens for a given mint. So let's make that. We're going to make a key pair for our mint authority. And we're going to run the command Solana keygen grind. And we're going to say -- starts with. And we'll say BOS, BOS, and then 1. And I'm not a good typist, especially when I'm recording. Solana keygen grind starts with BOS 1, and if you give it a moment, it will go and make a key pair file. So there we go. Our file is called BOS something.json, whatever the public key is that matches the private key inside. So we now have our BOS something or other.json file. Let's make Solana use that key pair to sign all our transactions. So we do Solana config set -- key pair BOS something seg04.json, whatever your JSON file is called. And it'll respond immediately, and we can see that our key pair path has now changed to be whatever our BOS file is. At the same time, we should also make sure that the Solana command line tools are using devnet, because that's where we're going to make our token. That is Solana config set -- URL devnet. And you can see in the response that the settings are now updated to use Solana devnet. We can also double check that if we just do a Solana config get. At any time, we can always check what key pair file and what network we're connected to. So we've created our Mint authority, but because this account's going to be writing to the blockchain, they need some SOL to make those accounts. So we have our boss something or other is the public key of our Mint authority. Let's go to, say, faucet.solana.com, paste in that wallet address, and look, 1 SOL is fine, 0.5 SOL is fine, and we'll ask for that SOL on DevNet, and we can get some free DevNet SOL. Excellent. That says airdrop was successful, and if we do Solana balance, we can see that our balance is 0.5 SOL. So we've made our Mint authority, which is going to be the boss of our token, the account that has the permission to create new tokens or mint new tokens. And we've given our Mint authority a little bit of SOL to make new accounts. Great. The next thing to do is to actually make the token mint. So we're going to give our token mint a fancy address. It's just going to start with MNT, just so we can remember it's our mint. So we'll run Solana keygen, and we will say grind an address that starts with MNT, and we only need one of those addresses. Give it a moment, and it will create an address that starts with MNT something.json. So that address is where we're going to put our token mint. Let's put a token mint at that address. That is SPL token, create token, and we're going to specify the program ID of the token extensions program, which starts with token and then a Z and then all this other stuff. So I'll just paste that in. And we want to use the metadata extension because it makes our lives easier. Enable metadata. And we will say our address to use to make our new token. Great, that's done. So we've now made a new token on Solana. The address of our token is the same as the one we ground earlier. It has 9 decimals, which means that if you've ever transferred SOL before, you'll notice that to send 1 SOL, you send 1 billion LAM ports. It's the same with our new token. We've specified 9 decimal places, so you send 1 billion whole minor units to send 1 major unit. This is actually not even a blockchain thing. It's a financial programming thing. Whenever you send someone $2.50 in the real world, you probably actually send them 250 cents. And it's because computers don't handle decimal very well. They work in binary. So if we always send whole numbers of whatever the minor unit is, cents, LAM ports, your own token's minor unit, it makes it easier for the computers. So we've made our new mint. Let's go check it out in Solana Explorer. So I'm in Solana Explorer, and I will say devnet, thank you very much. And I will paste in our token mint address and check it out. It says unknown token. It says a token 22 mint, which is using token extensions. There haven't been any tokens minted yet. 9 decimals, as we just talked about. And there's not really that much here. There's no kind of metadata or anything yet. And it says unknown token. So let's fix that. Let's add some metadata. Now, to do that, you're going to need to upload, firstly, an image and then a JSON file somewhere public on the internet. If we were making a token for mainnet, a real serious production token, we would probably want to use a decentralized storage service, somewhere like Arweave, or Iris, that is basically kind of like a blockchain, but for JSON files and images and all that kind of stuff.
rather than Solana is a blockchain for transactions like traditional blockchains. These decentralized storage services are designed to keep things online for a really long time because they're not owned by anybody, and they're resilient to attacks and all this kind of stuff. They're a good place to put something that you want to be around for a really long time. In our case, this is just a test token. So we're going to use GitHub, and we'll just be using those raw GitHub links. The important thing to realize here is that our link has to just open our image file or our JSON file directly. No HTML, no anything else around. Make sure that when you visit that link in your web browser, it just shows an image file or some JSON, depending on the image or the JSON. So upload the image first, add it to a metadata file that looks a little bit like this. You'll just have a name, a symbol, a description, and the image that you uploaded earlier. Take that metadata file and upload it to somewhere public as well. Make sure that you have a URL that loads your metadata file directly in your browser. For example, I have one right here. There we go. So I can now add that metadata to my token. So SPL token, and we're going to say initialize metadata, and we're going to specify our token. I'm just going to get it from the file name, our MNT file name. And we're going to specify a name for our token and a symbol like. And then finally, that URL to get to that JSON file. And then Solana will go and take that JSON file and put that data, directly inside the blockchain. You'll see everything has gone successfully. And if we go back to Solana Explorer at this point and reload our token, you'll see unknown token has been replaced by example, as we specified before. And now there's a whole bunch of metadata, our name, symbol, the URI with the image. That's all now showing on Solana Explorer. So great. We now have a token mint, and it looks nice. So we can use this token mint to mint tokens. Let's mint some tokens, and as the mint authority, we can mint them into anyone's account, but let's mint some into our own account so that we can transfer them out to other people if we like. SPL token. We're going to need a token account in our personal mint authority account just to store these tokens. So create accounts for this mint. So we're just making a PDA or an associated token account to store just these tokens in our own personal account. Once we've done that, we can go and mint some new tokens. That's SPL token mint our token, which is MNT something or other. And how many tokens do we want? Let's say 100, maybe 1,000 tokens. So that's good. Done. Let's go and look at, firstly, our token mint and then our own personal account to see what's changed. So if we go back to Solana Explorer and look at the token mint again, you can see the current supply, which is the amount of tokens that have ever been minted, is 1,000. In fact, let's mint another 1,000. You can see Solana Explorer updates again, and you can see 2,000 tokens have been minted. Also, let's check our personal account as the mint authority, which we called, what was it, BOS something or other. There we go. And if we check in our own account, we can see that 0.5 SOL that we gave to ourselves earlier, minus a few transaction fees. But more importantly, if we check in tokens, we can see that we have 2,000 of these tokens, and the type of tokens is our token mint address that we made before. We can transfer these tokens, we can burn them, we can delegate them, we can do all the normal things we do with Solana tokens. So there you go, you now have your own token. I hope you enjoyed this, and I'll see you in the next chapter.
Now let's make an NFT. And here's the good news. You already know most of what you need to make an NFT. NFTs are just SPL tokens, exactly like we made in the previous lesson. Just like other tokens, they are minted from token mint accounts, stored in associated token accounts, and transferred with the token program. However, NFTs have a few characteristics that are distinct. Firstly, they're unique, i.e., each NFT only has one ever minted. Also, they can't be broken up. In other words, each NFT has 0 decimal places. Additionally, the metadata for an NFT contains links to another file, stored on a file storage service like Iris or IPFS. This off-chain metadata file has links to media files like images, videos, or 3D objects, any traits the NFT has, links to the project that made the NFT, and more. Authenticity is also handled differently with NFTs. With regular tokens like USDC, we know they're authentic because their mint address matches the official USDC mint address. Since each NFT has a unique mint address, we use the concept of collections to verify that each NFT is actually minted by the right project, and not a forgery some person created. Let's go make an NFT.
All right, so let's make an NFT. We're going to start by making a folder called new NFT. We will change into that, and we will run npm init-y to create a blank npm project, a package.json, and all those things. We're going to install a couple of packages as well. We want to install from the Metaplex Foundation a package called MPL token metadata, and also a package called, also from the Metaplex Foundation, UMI bundle defaults. UMI, by the way, is the Japanese word for sea. You'll notice a lot of things in Solana, like sea level, like anchor, have names based on seas or oceans. Cool, they're all installed. I'll just clear my screen. And let's go make a new file, and we will call it create collection.ts. So we have our create collection.ts here, and we're going to start, oddly enough, by making the collection. As I mentioned before, NFTs, unlike regular tokens, are unique. So whereas normal tokens have multiple tokens, many billions of tokens in some cases, or with a single mint address, each NFT has its own mint address. So there needs to be some way to bind all those NFTs together and also confirm that any new NFTs are actually produced by the owners of that collection. So that's why we have collections. So we'll start by making that collection, and we're going to import a few things. We'll take create NFT. Collections themselves, by the way, are also NFTs. Fetch digital asset, and what else? MPL token metadata. MPL is Metaplex. That's the company that maintains the Metaplex NFT tools. From at Metaplex Foundation, MPL token metadata. That looks good. It's just shown up as gray because we aren't using it yet. We're also going to import a few things from Solana helpers, and I should install the helpers as well. npm I at Solana developers helpers. So let's import a few things from that helpers file. That's airdrop if required. Get explorer link. Get key pair from file. From Solana developers helpers. That looks good. There's a few other things as well. We also want create UMI. Our UMI instance is just a way we can talk to Metaplex's tools. We can talk to other tools with UMI as well, but nearly all of the time, in fact, people just use it to talk to Metaplex tools. Metaplex Foundation. It is from UMI bundle defaults is the name of the package. There we go. We'll want a few things from Web3.js as well. That's actually already installed for us because it's a dependency of some of the other packages. We want connection, and we want LAN ports per URL from at Solana web3.js. Oh, and I haven't spelled connection properly. And lamports per URL, lamports per sol. I don't know why I thought lamports per URL. That looks good. Excellent. So we're going to create a connection. And we'll connect to whatever the URL for DevNet is. So cluster API URL for DevNet. And probably also want to import cluster API URL as well. Oop. And we'll also want to import cluster API URL from Solana Web 3. So we have our connection. We'll want a user. So get key pair from file. If we don't specify the file to use, it's just going to use the id.json that's in our home folder. So that sounds good. And let's give ourselves some sol if we don't have any. So go await, airdrop if required. Connection to whose public key? The user's public key. Oh, I just realized I forgot the await. There we go. Await, get key pair from file, user.public key. And we want to get 1 Solana, so 1 lamperts per sol if our balance ever falls below 0.5 lamperts per sol. That looks good. Excellent. Let's also just console.log loaded user, and then we'll just say the user.public key. And probably want to say to base 58 so it prints out in the usual string of letters and numbers that we're used to seeing Solana public keys as. So let's make our Yumi instance. This is going to be, as I mentioned before, how we talk to Metaplex's tools. So const Yumi equals create Yumi. And we'll create our Yumi instance just using the same endpoint as our connection. So it's a Yumi connection to DevNet. We'll tell Yumi the programs we want to use, which in nearly all cases, as I mentioned before, Yumi is pretty much a Metaplex thing. So the programs you'll probably want to use are MPL token metadata. Sounds good. So MPL token metadata is actually a function. So we go yumi.use and then we run NPL token metadata. So we're going to make a Yumi version of our user key pair. So Yumi has its own format for key pairs. So we'll just call it Yumi user equals yumi.eddsa dot create key pair from secret key. And just say user.secret key. So this is just a copy of user, but it's just in the format that Yumi uses for secret keys. Again, Metaplex has their own ways of doing things, so these might be a little bit different than the normal Web3.js ways that we've been using in previous lessons. So we've made our Yumi key pair, and we'll go yumi.use key pair identity, and then Yumi user. And I think we need to import key pair entity, and we need to import key pair identity so we can get that from Metaplex Foundation Yumi, and that looks good. Excellent. Great. So we've console log, say set up Yumi instance for user. I always like adding console logs, just if we're making command line tools, it's nice to have a little bit of feedback. So we've loaded our user, we're connected to DevNet. We've given the user some DevNet sol if they needed to. We've made a Yumi instance so we can talk to Metaplex's tools. And we've set that Yumi instance up to use our user as the default signer for any transactions. That's good. Let's go make the collection. So we're going to do const collection mint equals generate signer UMI. So it's going to make a key pair using UMI. And this is our transaction that is going to create our collection for us. Await create NFT. As I mentioned before, collections themselves are NFTs. They're just NFTs that point to other NFTs. You can even do fancy things like collections that point to collections. Go check out Metaplex's docs for that.